The Schaeffler Group is a global automotive industrial supplier who craft high-precision components for engines, transmissions, and chassis. Their Fort Mill 1 plant specializes in the manufacturing of needle thrust bearings, which are used in both consumer and industrial products. The first step of this manufacturing process is to stamp the upper and lower flanges of the bearings out of sheet metal. A modular stamping press rapidly forms these flanges, and though efficient, defects can occur if debris is stamped into the parts or if the stamp becomes misaligned. Currently, Schaeffler accounts for this by having thorough quality control systems at the end of the assembly process. However, our project aims to catch defective parts directly after stamping and before valuable time and resources are wasted on them in subsequent production phases. Our project objective is to design a system that can collect flanges from the production line, scan them for defects such as trash, scratches, or general deformation, and notify a plant operator if any are found. The approach we took involves two linear actuators that drive plastic platforms under a part conveyor to passively catch flanges. Then, they're passed through a brush to ensure that only one makes it to the analysis phase. A Keyence camera works in tandem with a spectral lighting dome to extract the contour map of the part, which is analyzed using an AI-driven defect detection. The platform then flips the part for second side analysis, and once both sides of the part are scanned, parts are dropped into a bin depending on the results. Building this multi-part system involved cutting and joining the 80/20 frame, assembling the linear actuators, rapid prototyping of the platforms, and wiring together the control and movement systems. Developing the software for the Keyence camera involved first stabilizing its position, then placing both good and bad parts under it to train multiple AI tools via Keyence's proprietary software called VS Creator to recognize which way the parts were facing and if any defects were present on the different part types we were asked to analyze. Once the prototype was completed and fully functional, the team tested the device. The system is able to accurately extract and scan flanges from the assembly line and can detect defects such as debris or deformation. Schaeffler's quality control process is critical to the safety of their clients and customers. We have built a device that assists this process by catching defects early on in order to save time and resources, adding value to defective parts. We have worked together to provide Schaeffler Group with a prototype analysis system using an AI camera that can be utilized during everyday operation at their Fort Mill 1 plant.